Hi everyone! Yes, we are going to make a rocket! So I will present you on this table all the parts that we are going to need. So let's cue the music! So I hope that this is all that I need to build this rocket, but this rocket is going to be a little bit different because I know nothing about aerospace engineering and I don't know how to use an inertial measurement unit or how to do proper thrust vectoring. So what I'm going to do is to have the thrust on top of the rocket and the weight on the bottom. So I've designed this rocket to have the center of gravity as low as possible and the pulling power as high as possible to see if this thing can keep itself on equilibrium. So I will start building it and I will show how I'm planning to do it along the way. Let's make some space. First things first, I will put the main engine on, which is going to be this 3 kg thrust EDF that I bought on Hobby King, which will go in this hole in here. And there is a hole in here for the wires of the EDF because I want all the wires to go through the main hole in here, which might not be possible, but I will try my best. I don't know if you can see it, but the distance between the motor and the chassis of the rocket is too tight and it is not touching now, but I don't want to have that risk. So I will try to modify the hole a bit with my deburring tool because now it's going to be easier. Okay, the motor is in and I printed this ring which has 6 holes for 6 screws that will keep the EDF in position instead of flying this way. So now that the motor is in place, we could just give it a go to see if it works. This is the 100 amp ESC that I choose for this project, at least for the main engine, and I made the wires that go to the motor longer because I need the batteries to be on the bottom of the rocket, and I've read on the internet that it's better to make the motor side cables longer than the battery side cables longer. So that's what I did. Success! Where's the radio? Radio kill the rocket of Ivan. I have no idea of what happened there, but my ears. Woo. I guess I've shown you full thrust. Woo. I will use this, sorry. It's rotating the wrong way. And it failed because I did reverse the remote for the tank and I forgot to... I'm shouting, right? I did forget to reverse the remote from the tank test and it was, well, you know. Pulling power confirmed. I will reverse the remote before I get another scare like that. Always check if you have disconnected everything before doing something like that. I'm just about to have a heart attack. But pulling power confirmed. We got liftoff. I have to, let me show you. I have to reprint this part in here, but otherwise, well, and in here it is completely destroyed. I might have to be more careful with these things. Woohoo! Well, I will finish reversing the remote. There is nothing connected to it. I will do something. I don't know what, but I will do something. Okay. Well, I will check if the motor still works, because you know what happened. It works. Well, I just set another print for this part, and I will keep assembling the rest of the parts. That one is going to take more than one entire day, which is what this one took. But we still have lots of work to do. I have my 10 fingers on my hands. Please don't do what I do on this channel. Please be careful. I will try to be careful too. Don't try this at home, unless you know better than me what you are doing. This is in the top 10 of this year's scares, with that spider, no. So I will mount the propellers that will represent the side boosters on these things in here. And as you can see on these ones, I already made the cables longer. Now the other half. So one side booster ready, one to go. And the second one is ready too. And I have all those tiny ailerons that I will put on these really tiny and really fast servos that I will hopefully use to control it. 1, 2, 3, 4, 5, and 6. And as I don't have the final version of this part, I will use this previous version at least to do this test assembly, because I cannot wait. It's a rocket! This one is a little bit broken, but I think it can work. You will not believe how many times I failed to follow my own assembly process. I forget how I devised the thing. I have to mount this first. I left in here a channel for the wires. So, okay, this one broke and I'm now recovered of the big scare that I had. And as I don't trust myself about not breaking another one, I did print two, because this is a very important part of the rocket. And you might be wondering, why the hell are you putting the propeller and everything on the top of the rocket? Well, because there is a guy that is making another rocket with a very different approach and technology. And that guy is the very same James Bruton. Yes, that James Bruton. Sorry mate if I destroyed your name or your surname. I'm really bad at this. But if you don't know James, he has made lots and lots of really cool stuff. He has made several Iron Man suits, an exosuit, very big drones, Batman suits. He is now making a big dog robot, and he is releasing everything as open source so anyone can replicate it. So please go and check his channel, because it is really awesome. And what's that different approach? Well, I'm going to propel this thing from the top so it stays in equilibrium taking into account that I have to put a very low center of gravity, and he is going to be propelling it from the bottom using electronics to move the propellers from the bottom to keep it upright. So I'm building the red rocket, he is building the blue rocket, and he is going to come and visit me to test the rockets. So go and subscribe to his channel if you don't want to miss it. So let's put some things inside this one, and the one thing that I did wrong last time was to put first the EDF in here instead of the side boosters, which are bolted in here, and it is impossible to do that with the EDF on. So I will put first the side boosters. So the two side boosters are ready, which are a slightly modified version of the propellers of my self-propelling unit, which I know I have to finish, don't worry, I have it in here. And I will use colored zip ties just to know which wire is which, because when I mix them I will know where they are coming from. So for once, let's be prepared. So here, 3 wires from the first motor marked with yellow zip ties, so I don't mix them with the ones from the other motor. Those are already a lot of cables. And 3 more. Let's put the main EDF on. So, how does it look? So, this is where the raw power of the rocket is going to come from, but I'm not going to leave it like that and let it go straight up. And even if I try to do that, if this is counter-rotating this one, which it is because I put the right propellers on and I hope to wire the Yessss right, this one is going to try to rotate the rocket because there is only one of it. So I will try and use one of these HELI gyroscopes with these very high speed servos that had these kind of rudders on them, and that will be controlled by the gyro. And I plan 3 stages of servos. The first ones on these holes in here are going the ones that will try to counter rotate the EDF, and then there is another stage in here and another stage in here to move it sideways and forward and back. Hopefully, but this could even not go straight up, so that might not be even important. The next thing that I need to do is to wire all those servos, so let's do that. So I spent a lot of time trying to learn how to mix channels on the radio transmitter and how to reverse them, and I think I have now more or less a grasp of how to do that, and I will make a quick pulling test of the motors to see if I did it correctly. So let's get ready for that. It is reversed. Okay, it works with one. And now let's try with both Yessss connected, which I'm really scared about. I will connect this in here, this in here, and this in here. So after a few rewirings and tests and all, I think we have thrust, controlled thrust. So let me show you what I'm talking about. And there is nothing in the table, because if I try this with things in the table, they come out flying off the table. So let's try it out. I don't know if I can show you this. Let me see if I can show you this properly. This is a bottle full of water. There it is in the table. And now it is not on the table. Do you think we will have enough thrust. Oh, so I will put some servos on it and I will try to show you how they are supposed to work. First, I will need to put larger cables on them, so give me a second. All the wires are longer now and I will test them before putting them in the rocket to see if they work, because if they don't when they are on the rocket, this is going to be 1, 2, 3, 4, 5 and 6. And now it's time to put them on the rocket, and there is not much space inside with the cables and everything, but I will try my best. So all the servos are in, so I will put the next section of the rocket. And now I need to connect the gyro to the top two servos, but this has only one input, so I will make a splitter really quick. And there it is, a perfectly good splitter. So I will connect the two top servos to the splitter and to the gyro. And this one is supposed to go to one of the outputs from the receiver. This thing in my hand is the gyroscope. If I don't move it, the two fins in here don't move, but if I rotate the rocket, the two fins, they compensate the movement. It's alive! Alive! So after a lot of fiddling with this remote in here, I managed to do what I wanted. All the servos move as expected, and this took much longer than I hoped it would take. But let me show you the entire setup. I put this like this, and as you can see, the two servos on top move. And if I rotate the gyroscope, which is in here, you see, and if I turn the gyro, the servos move trying to correct the spin. Good. And then if I move, let's try and show this on camera with one hand. There is only one thing left, the throttle. So let me put everything together and give it a go to see if everything works as expected. The bottom part. And another thing that I wanted to show you is how far back is the center of gravity, which I need. It should be even much farther. It's more or less in the middle. So I might even have to add weight to the bottom so this thing goes straight up. But let's make a test first. Let's bring it here. I don't know how am I gonna do this. I don't know. I will try to do it. Okay, there is liftoff, and I cannot let it go. I will try again, but okay, that's all I can do in here, and I think that James is going to get to the same conclusion. Please go and check his channel because he does all this amazing stuff. Did you know that he's making a replica of the Boston Dynamics Big Dog in a small, not that small size, it's pretty big, and he's using the same motors that I'm using with my tank, but in a much more subtle and dangerous way. And I'm pretty sure that he's having much less trouble with all his electronics than I'm having with a single gyro. So you will learn a lot from him. So I will leave the links to James's channel on the description. Go and check it out, and if you like it, go and subscribe to his channel too. So the next time that you see this rocket, and James's rocket is going to be when we are together testing them. I'm still not sure where we are going to test them, but I am absolutely sure that it's going to be epic. So again, go and check James's channel. That's it for this week. Thanks a lot for liking, sharing, commenting on my videos. It helps a lot. If you are still not subscribed, you are going to miss the launch. And now please go and make something.